Forge welding. Some ancient mystery lost to the past, only something that can be used by the best master smiths? Well, of course that's not true. Forge welding is one of the fundamental skills of a blacksmith. Now, simply put, forge welding is just bringing multiple pieces of material up to near melting heat, really a high heat, and then fusing them together under pressure. Typically, that's pressure from the hammer at the anvil, but it can be done on a hydraulic press, power hammer, rolling mill, lots of different ways to make the weld. One of the reasons I consider forge welding a fundamental skill is that it opens new doors for you. It allows you to do things that might be difficult otherwise, like adding a separate bar for the reins on this set of tongs is easily done if you know how to forge weld, but drawing that out of heavier material is a whole lot of work if you're only working by hand at the anvil. So if you don't have a power hammer or press or something else to do that heavy work of drawing out, forge welding allows you to do these things fairly quickly and efficiently by hand at the anvil with just the hammer. Forge welding is what you need if you're into pattern welded steels or Damascus. That's a forge welding process. If you want to make chain, making chain in the blacksmith shop is typically done through forge welding. Axes, adzes, all those kind of things, often done by forge welding. And when you get into ornamental work, the sky is the limit for how you might be able to use forge welding to join the various elements. Well, modern welding equipment, stick welding, MIG welding, TIG welding, has largely replaced forge welding in a lot of modern blacksmith shops. I think it's still a valuable skill, one you should know, and then you can decide which works best. Instead of just MIG welding, because that's the only thing you know how to do, you can say, well, I think forge welding is going to be better for this. Or maybe forge welding isn't the best and I prefer to do the MIG weld. There are always going to be options, and forge welding is just another tool to add to your toolbox. So to be able to forge weld, what's needed? Of course, the first thing to consider is you have to be able to get it hot enough. If you can't get a good high heat, and that is a bright orange, lemon yellow, maybe a white heat, everybody sees that heat a little bit differently, so you have to know in your mind what that heat looks like to your eyes. It doesn't really matter what color I describe it. I think of it as a very bright orange, other people lemon yellow. Working in mild steel, for the most part, white hot is going to be too hot, but maybe that's the way you see the heat, so you just have to learn what that heat should be. But it isn't as simple as just getting it that hot. You can get it that hot and still not have a successful forge weld because the joint isn't properly prepared, or because your fire is dirty, because the material is oxidized. There are lots of reasons you could screw up a forge weld. So having a good, clean fire, if you're working with a coal fire, having a gas forge that is not oxidizing the material and leaving a heavy layer of scale right at that forge weld is important if you're working in a gas forge. And that's, again, something you just kind of have to work through. There's a lot of practice involved with this, but we're going to talk a little bit about what makes a good fire. We're going to deal mostly with the coal forge, although this applies to coke, charcoal, whatever you're burning in a solid fuel forge. The concepts really do remain the same. But then we'll talk a little bit more about gas forges and induction forges and what their place in forge welding might be before we get to the end of the video. So what makes for a good fire? First, you need good fuel that has high BTU output. Not all coal is created equal, so having good high BTU coal is important. Having clean coal is important. If it's full of a bunch of dirt, sulfur, all of that kind of junk, you're not going to have as much luck forge welding. But the way you build your fire is also important. So here's a typical fire pot for a coal forge. And the air comes in from the bottom, at least in my forge. There are side blast forges, and it's perfectly okay. You can weld in either one. Which you have and which you prefer is kind of a personal choice, and it depends on what part of the world you're in. Some parts of the world, side blast forges are most common. Other parts of the world, bottom blast forges like this are most common. What the air is doing is bringing in oxygen. More oxygen creates more heat. It makes the fire hotter. That makes sense. So you got your fire in here, and this is where all the oxygen is going. The problem is oxygen causes oxidation and forms scale on your material. Oxidation is as big an enemy as dirt is in your fire. So you don't want oxidation. You don't want your material to be down in here. If you have a riveter's forge or something like that that doesn't really have a fire pot, you may not be able to get your material up high enough to be away from the oxidation. Right in this area though, is where you want to put your material for forge welding. The oxygen should be consumed by that point, and that should have the maximum amount of heat right there. You go higher than that, it's not going to be quite as hot. Go lower than that, you're going to start oxidizing, and you can actually burn material. If you see a lot of sparks when you're forge welding, you either got it too hot or had too much oxygen, and you could actually burn it even though it isn't quite up to heat yet. It also helps to have fuel on top of the material up here, and that helps insulate it and reflect the heat back down on the fire. But this is the neutral zone right in here. That's where you want to be heating your material when you're forge welding. Now, besides having a high BTU fuel, good clean fuel, you don't want to be putting fresh green coal on the fire while you're forge welding. That just robs heat energy. You want your coal to be coking and be putting coke on the fire while you're working. Or if you're using commercially made coke, you can just put commercial coke on the fire while you're working and keep bringing that in so you've got good fresh fuel for forge welding. Same thing applies to charcoal. You can forge weld just fine in charcoal, but you're going to need a lot of it because it eats it up really fast at those high heats. Now, another enemy while you're trying to get a good heat is clinker in the fire. Clinker is all the junk that's in the coal. It's welding flux, it's scale off the material. Whatever's in there that isn't carbon to burn kind of melts down and forms a glassy substance that's called clinker. If you've been working for a while and you don't know that you've got a good clean fire, it pays to stop and clean out the clinker. Now, I don't have very much clinker in this fire. It's a fairly fresh fire, but there is a little bit from doing that one side of the tongs. It also pays to dump any ash that's in the bottom of the fire pot. You just want good fuel in here when you're forge welding. Before we go any further in our discussion, let's talk a little bit about flux. Flux is not some sort of magic dust. It's not glue. It does not make the weld for you. You can weld without flux if all the conditions are right. Flux just helps a little bit. Its main goal is to clean the material. It dissolves the scale and crud that's on the material and kind of etches the material a little bit, leaving it cleaner. And then because it melts as it's doing this, it's sort of like a molten glass, seals oxygen out, helps prevent oxidation. And those first few hammer blows of a forge weld where you see all those sparks, well, that's the molten flux flying off. So if your weld is designed properly and you set the weld properly, all the flux and all the crud that's been caught up in the flux gets squeezed out of the weld so there's nothing trapped in the weld. But it isn't magic. If you've got a dirty fire, if your fire is not deep enough, if it's an oxidizing fire, flux is probably not going to make the difference. One of the easiest things that works as a flux to come by is 20 mule team borax. This is not laundry detergent. It's actually a mineral. Sodium tetraborate, I think, is what the mineral is. And this melts and becomes a pretty good flux. I've been using the Iron Mountain flux lately. This is a pretty nice flux, comes in a little squeeze bottle. I thought the squeeze bottle was a real gimmick the first time I saw it, but I've since really started to like it because it's so easy to apply. You don't need a flux spoon. You don't have to stick your hand in the flux. You just squirt a little flux where you want it. Both are powders, and you can buy anhydrous borax that has no moisture in it. Problem is, as soon as you open the container, it starts to absorb moisture, and unless you can keep it airtight in the shop between uses, pretty soon it just picks up enough moisture from the air that whatever you spent extra to get anhydrous borax is probably wasted money. A lot of flux compounds, Iron Mountain Flux, Easy Weld, things like that, have iron filings in them. That helps a little bit too. Sometimes you see sparks from those iron filings, and that's a good indicator you're getting close to welding heat. Now, my personal observation on flux is that borax, when it melts on the material, is slippery. This really helps get it down deep inside of a joint. If you're welding cable to make a cable axe, cable knife, something like that, borax really soaks down in where you can't normally get flux. So it's really beneficial for that. But if you're doing a two-piece weld where you come together at the anvil, that slippery nature oftentimes means the first hammer blow, you're just sliding the pieces past each other, and it makes it really hard to get the weld to stick. Easy Weld and the Iron Mountain Flux are kind of tacky. The iron filings help with that, but for the scarf welds or the two-piece welds, drop tong welds, whatever you want to call it, I really prefer to use one of these commercial flux compounds over the borax. Okay, I've talked long enough. Let's make our first forge weld, and let's make it easy on ourselves and leave everything connected. This is just a sample weld to practice getting to welding heat. We're not making anything out of it. We're just learning to recognize a proper welding heat. I'm going to start with a piece of 1/2-inch bar. I'm going to nick it about 3 or 4 inches back on a Hardy, about halfway through, and then fold it back over on itself. This way we don't have to be manipulating material as we come to the anvil. All we have to do is make the weld. Got about halfway through. Now before I bring that all the way together, I'm going to put a little bit of flux on there. In this case, I'm going to go ahead and use the borax since it's readily available at most grocery stores. The flux spoon keeps your fingers away from the heat. And you let that melt in. Then we're going to go ahead and close that up, just light hammering. You don't want to squirt it all out. You just want to bring the sides together. You want to bring this up to welding heat very slowly so you don't burn the outside of the joint before you get welding heat all the way down inside the joint. There's a little bit of clinker right there. And it pays to gently turn the material in the fire as you're coming up to heat to get a good even heat. Just try not to be too energetic with it so you don't knock all the flux off. A little poker helps push the coal or the coke away. And you can see down in there. I don't know if you can see it on the camera or not. You can see the yellow, bright, but you can see the bright orange yellow heat down here to the left, and the material is not that color. When the material starts to disappear in the fire, you're probably at welding heat. You don't want a lot of sparks. Sparks from the iron and the welding flux is okay, but since the borax doesn't have any, sparks would be bad. That means you're burning the material. That's a welding heat. You're going to go with light, rapid blows starting at the end and work back, and only the part that's hot. This section up in here is not hot enough to weld. There's no reason to hammer that. If you think you've got the weld, it's okay to refine the joint a little bit, but if you're not sure, it pays to wire brush it lightly. Put a little bit more flux on it, and then go back to the fire. If the weld is not completely stuck and you're losing your welding heat, there is no reason to keep hammering on it. Get it back in the fire, take another welding heat, and then finish getting the weld. If the weld is stuck, you can start refining it as it cools off. Again, we're looking for that bright orange to lemon yellow. On your first heat, it pays to use light, rapid blows. As you get into these subsequent heats, heavier blows are okay. The reason for light, rapid blows is you don't want the material to be shifting under the hammer blows. You want it to be welding. If you hit too heavily, it might just be moving around some. Now, I'm pretty comfortable that I've got a good weld. Let's go to the vise, put just the last ½ inch of that in, bend it over, and see if it opens up. So if I've got a good weld, this should not open all the way up. And it bends up here and does not go down into where the weld is, even though that's a thinner area and would want it to bend easier. So that's a good weld. It's also the start of a ram's head or a dragon or something like that, or a fireplace poker. And this is a very popular weld to make fireplace poker points out of. Matter of fact, let's just go ahead and look at this again, and that's what we'll do. Start by cutting this off. The first thing I want to do is just draw this out to a nice point, and that will be the hook part of the fireplace poker. Then we'll do the same nick halfway or so through the bar and fold it back on itself. For a poker, I don't want to leave as much material as I did for that first weld. I'm just going to fold about that much over. But you do want to make the weld in full thickness material because it draws out really fast at a welding heat. We'll go ahead and flux that. The flux on the surface doesn't really matter. What you want is it to get down in, and I just put enough on there to make sure it flows down into the joint. Using mountains of flux doesn't help any. You just need enough to coat the inside of that joint a little bit. Now I'm only going to weld that last inch. Again, you want a bright orange or lemon yellow heat, but try to avoid sparklers. You don't want to burn it up. Drawing this out to a point. Again, this isn't a bad start for any number of fantasy figureheads until it gets right down to a point, and then it sort of would look funny as a dragon with a pointy nose, I guess. Yep, that's shearing past itself, so I've sheared that weld. I got a little too aggressive with it. I should have taken another welding heat. But let's see if we can weld it back together. Sometimes you can save this stuff, and sometimes you're better off just starting over. Now, a perfect forge weld should be as strong as the parent material because you're fusing it together. It's a good weld. It's hard to tell if you have a perfect forge weld, though. If you have any inclusions, any scale, trapped flux, things like that, it may not be perfect. And as you start to refine the weld, if it isn't perfect, this kind of thing can happen. But for most things that you're forge welding, it really doesn't matter that much. The little hook on this isn't under a lot of stress. Welding ornamental pieces onto a gate or a railing, again, low stress. And the heavier the weld is, the easier to get it all right because it holds heat longer. Well, I think we were a success there. So sometimes it's possible to save it. If you forge it out and it's too thin, probably better to start over. Give our point just a little bit of shape here. That makes for an interesting fire poker. Just depends on what you want. But my intent here is not to show you how to make a fire poker. That's just one application for this style of weld. There are other places where you just need to build up material, and folding it back on itself can be a good way to do that. Also referred to as a faggot weld, as in a faggot of sticks being a bundle. Now I talk about not getting it up to a sparkling heat, not burning it. What does that really look like in its extreme, and what's the problem with doing that? Let's put this bar back in and bring it up to a high heat, and I'll show you just exactly what happens when you get it way too hot. And I can see some sparks coming up in the fire. A few sparks like that aren't really going to hurt anything. We can get it a little bit hotter. This is getting way up into that lemon yellow range. Seeing even more sparks now. And you can see the outside starting to ooze a little bit. That means it really is starting to burn. A little bit of that is a good sign of welding heat, but this many sparks is just a bit much. Okay, so right away you can see that that just looks horrible. And while we can force that together, we are never going to get rid of that burned appearance on it. It also breaks very easily when it's been overheated like that. And sometimes you smack it and it's like smacking a hunk of cheese. It just goes bleh and falls apart in all sorts of ways. So that's why you don't want to get it way up into a sparking heat. Few sparks are okay, especially if you're using flux that has iron filings in it. But if it looks like a 4th of July sparkler coming out of the fire, it's a good chance you've ruined it. Every now and then you get lucky, but in most cases, you're going to have to start over. Now, can you do all of this in a gas forge? Not every gas forge will get hot enough to weld in. They're all a little bit different. It depends on the altitude you're at. I have a little bit of trouble at my altitude. I'm at 6,500 feet. But by rejetting my gas forge, I was able to get it to welding temperature. So it is possible to weld in a gas forge. Gas forges are great for bigger forge weld. If you're doing pattern welded steel, you're welding up axes, adzes, things like that, a gas forge is wonderful. For welds that are 2 pieces, like doing a set of tongs and bringing the reins and the jaws together at the anvil, I find gas forges to not be real practical. And even for doing this fire poker weld, you're heating up a huge amount of material for a little tiny weld zone. So I don't really like gas forges for that. The other big downside to welding with gas forges, if you're welding with flux, and for most open welds, you need flux in a gas forge, the flux eats the lining of the gas forge. It's really hard on the ceramics, and you will wear your forge lining out much faster. That's okay. You can usually repair that. You can reline a gas forge, and it's something you're going to have to do ultimately anyways, but it's going to happen a lot faster if you're welding in the gas forge. Now, if you're doing things like canister welds or wrapping your welds in stainless foil, doing pattern welded steel and things like that, a lot of times you can get by without flux, and then it's not a problem. But those aren't the kind of welds that I'm doing in my shop. So if I'm welding in the gas forge, I do use flux. The other forge that's an option is the induction forge. And the induction forge is wonderful for doing little welds. This weld we did today would have been a perfect example of a weld to do in the induction forge. It is very clean. It doesn't have any dirt. There's no clinker. It's just good, clean heat. And if you have an induction forge, I strongly encourage you to experiment with welding it. I think you'll find that it's really a pleasure. Now, I don't want to overload you with information here. This is just the very basics of forge welding. And this is where I think you should start. I think you need to practice this before you get too serious about trying anything fancy or using it in projects where the weld is really super important. Now, as I talked earlier in the video, there are other ways to weld in a modern blacksmith shop. There's no shame in using a MIG welder, TIG welder, stick. oxyacetylene torch, lots of different ways to weld. Forge welding is just another tool in your toolbox that will open doors that otherwise might not be open to you with the other techniques, and allow a lot of things to go smoother and easier than if you didn't know how to forge weld. A great example would be forge welded axes. It takes a whole lot of work to punch through a big piece of steel to create the eye for an axe, draw out that big piece of steel for the blade, and tool steels are a lot harder to forge. If you know how to forge weld, you can wrap the eye of the axe up out of smaller material, much easier to work with, and then weld the sides together, and then weld in a piece of tool steel for the cutting edge, and you end up with a very good axe, very traditional axe. That's the way axes were made for ages and ages before the big equipment was available to do it the way most of us do it today. So forge welding can make things possible that you might not be able to pull off in a small shop. In a larger shop doing fancy work, forge welding opens doors and ornamental work for joinery to do things in a more traditional way, which might up the quality and the price point your customers are willing to pay for your work. So I really think it's worth learning how to forge weld. But I think we're going to leave this video right there. We're going to look at more forge welds, look at doing chain links, drop tongs welds, other variations of forge welds that all have their own little issues on how to set up the weld, how to prepare the joint so that it goes together and makes a strong weld. I do want to thank you for taking your time to watch the video, with a special shout out to my channel members and my Patreon patrons. Channel members receive early access to the videos, usually a day or two early, while Patreon patrons not only receive early access, they receive the videos ad-free over on Patreon, and as much as possible, any sponsored content is edited out of the Patreon version. So if you're tired of the annoying YouTube ads, don't like seeing the sponsored content, contributing over on Patreon at the $5 level and above can help free you from the more commercial parts of the videos. Anyways, thanks again for watching. I hope you enjoyed the video. Get out, try some forge welding, enjoy the process, have fun, but stay safe, wear your safety glasses, and we will see you for the next video.